Hello, Shat. There is a scene in George Lucas's Revenge of the Sith where a character by the name of General Grievous spins his lightsabers in an attempt to assault Obi-Wan Kenobi.
This project will model the movement of his lightsabers in a sinusoid graph for 4 periods.
We will choose this scene because the lightsaber moves in a similar manner to that of a hand clock, which can be measured as a sinusoid easily.
We will be measuring the blue lightsaber closest to the screen. From 1 minute 9 seconds to 1 minute 10 seconds, or in 1 second, Grievous swings his lightsaber exactly 6 times, beginning at the bottom, which will be represented as a negative cosine.
That is 6 swings per second, or 4 periods every 2/3 seconds, or one swing for 1/6 of a second. And when converted to a period value by dividing 2 pi by 1/6, we get 12 pi.
After conducting further research, we can find that the average lightsaber is 3 feet long, which we will use as the amplitude.
Because the midpoint of the graph is Grievous's hand, we will have to account for the fact that it is one lightsaber's length off the ground by raising the midline 3 feet up. The final equation of the graph representing the movement of the lightsaber will be y equal -3 cosine 12 pi times x plus 3, with x being the height of the tip of the lightsaber and y being time in seconds. However, one must ask, what if he has a 4-foot-long steel pipe with a diameter of 5 inches and wall thickness of ½ an inch instead of lightsabers?
According to the National Association of Steel Pipe Distributors pipe weight calculator, the weight of this pipe is 96 pounds. But how do we use this to find the values of a sinusoid function? We can use the kinetic energy formula. Kinetic energy equals 1/2 mass times velocity squared, because if we can find the kinetic energy from the motor in Grievous's hand, we can find the velocity from already knowing the mass. To find the kinetic energy of the lightsaber, we need the mass in grams and the velocity in feet per second. The mass of an average lightsaber is 226.5 grams according to Google, and we already know the angular speed, 6 rotations per second. To convert angular speed to linear, we need to find the circumference, 2 pi r, of the circle that the lightsaber forms. The radius is 3 feet, the length of the lightsaber, so the circumference would be 6 pi feet, and the velocity is 6 times that, so 36 pi feet per second. To calculate the kinetic energy of Grievous's hand, we multiply 36 pi feet per second squared by 1/2 and 226.5 grams to get 146,772 pi of some arbitrary unit of energy. Now we backwards solve for the velocity of the metal pipe using the same kinetic energy and the mass of the pipe, 96 pounds, or 43,544.9 grams. 146,772 pi divided by 43,544.9 is 3.37 pi, then multiply by 2 and square rooted to find our pipe's linear velocity in feet per second, 2.59 pi. To get from linear velocity to angular, we use the circle the pipe makes while swinging circumference, which is 2 times 4 times pi, or 8 pi, and then divide 2.59 pi by 8 pi to get 0.32 rotations per second, or 1 rotation per every 3.08 seconds, which is the length of 1 period. The period value would be 2 pi over 3.08, which we will not simplify. The amplitude is 4 since the pipe is 4 feet long, and the midline is 4 above the x-axis because the pipe is swinging in a circle without being in the ground, and the graph is negative because it begins at the bottom like the lightsaber.
The final graph of our metal pipe is
Y equals -4 cosine 2 pi divided by 3.08 times x plus 4.
in both equations, the height above
The x-axis.
is the same as the amplitude because both the metal pipe and the lightsaber are being swung in a circle right above the ground.